Hello everyone and welcome to the networking tutorials in IT Guru 2, and this is the walkthrough video for IT Guru Laboratory 8, the routing protocol, RIP. As you may notice in the previous laboratories, Lab 6 and Lab 7, we used routers in our network, but I did not really talk about it. And if you did both laboratories, 6 and 7, you will have a general concept of a router. In laboratory 6 and 7, we use routers in the gateway and allowed clients from San Francisco and Los Angeles to access the server in Monterey Bay. In laboratory 5, we compared the VLAN function to one of the basic functions of a router, as it separates the broadcast domains in local area network. It's just that the router reduces broadcast physically by breaking the big network into a small network. So a router is a computer hardware that operates at layer 3 of the OSI reference model and TCP/IP model. The router connects to multiple networks, and when the router receives IP packet, it determines which network to reach its ultimate destination. And what routers care the most are the IP address in the data packets, where to forward those data packets in a network. If the router recognizes the packet's IP address, then the packet will be forwarded within the LAN or to the neighboring routers. So if the router recognizes the packet's IP address, then the packet will be forwarded within the LAN or to the neighboring routers. And if the router does not recognize the packet's IP address, then the router throws the packet to the border router or to the default gateway. So how does the router recognize an IP packet? So with the use of a routing protocol, routers are able to communicate with other routers by following a set of rules or standard. And with the routing protocols, it can determine its neighboring network by maintaining and updating the routing table. The information that the routing table updates or maintain actually varies, as it depends on the routing protocol used. So for example, let's say that RIP is used as the routing protocol. And basically, the information that the routing table maintains or updates in RIP protocol are the destination address, subnet mask, the metric or number of hops, the address of the next hop, and timers. So the routing protocol RIP, or the routing information protocol, is actually a distance vector routing protocol that determines routes based on the number of hops, meaning the number of routers to pass in traveling from one network to another. And RIP is the oldest routing protocol and still used because of its simple configuration. However, the simplicity of RIP protocol can be considered as its disadvantage due to poor determination of routes. For example, in this image, let's say R1 is trying to reach R4. Let's say the first route will pass R2 and R3 to reach R4, so that's 2 hops. And the second route passing R5, so that's only 1 hop. And what RIP does is that always choose the one that has the least hop, and so we'll choose the second route, which is the shortest route, yet it has very slow links. So RIP is not smart enough to determine that the first route is better because it's much faster to reach R4, though it has 2 hops. Also, RIP can only do a maximum of 15 hops, so if the destination is more than 15 hops, then it cannot reach its destination. And for our laboratory scenario, with the company's network expansion, let us study the company's routers using the RIP protocol, and assuming that the routers we use in the laboratory 6 and 7 are interior routers, let us find out how the routing traffic update and number of updates are affected when there is a link failure. Also, the goal of this laboratory is to teach the basic parameters of RIP and how to configure routers through RIP routing protocol using IT Guru. So let us start.